Hey science fans, so we're going to do the osmosis practical. Now osmosis is very important. It is the movement of water molecules from an area of high to low concentration through a partially permeable membrane until it reaches an equilibrium or a net movement of zero. Do you get that? High, low, partially permeable membrane. Now there's a required practical for this, so everyone needs to know this for trilogy, triple, etc. Now I'm going to do it with a potato. In the exam once, they asked the same practical with a carrot and people were like, what? But we did it with a potato. It can be done with anything that has cells. It's the same. Okay, so I'm going to do this practical with a potato and I'm going to be putting the potato in different concentrations of solution and seeing how that affects the mass and the length, basically how it affects the cells. What osmosis is happening, what would you expect? So we're going to go through those. You will get examined on this. You'll be asked about the measurements you take, working out percentage loss, percentage gain, and your general use of biological equipment and know-how. Now, this is the required practical. So we are investigating the effect of a range of concentration of salt or sugar solution on the mass of plant tissue. So it can be any plant tissue. Now, I always, whenever I see any kind of investigation, I like to highlight what are my variables, because then it means I can talk about my variables afterwards. So here, investigate the effect of a range of concentrations. That's what I'm changing. That's my independent variable. On the mass of plant tissue. So the mass is my dependent variable. So I'm looking at concentrations of a solution. So the volume of this solution is going to be my control variable and the type of plant tissue is going to be my control variable. I just look into those in different things. So these are the different skills, appropriate apparatus, techniques for observation and measurements of rate of reaction by a variety of methods, including uptake of water. So we can work out the rate of reaction by looking at how much plant material mass has changed over time. Okay, here's one of my control barrels. This is just a tray and a potato. Now what I'm going to do is I've got 5 different solutions. Well, I've got 4 different solutions and a control, which is water. And what I'm going to do is I am going to cut 5 pieces of potato. Okay, so I need to use a cork borer. So that's my 5 pieces of potato. So what I'm going to do is I'm going to cut them so that they are all the same length.
Making a good observation table is really important. Now, whilst this doesn't look particularly neat or brilliant, it's got everything you need. So you'll see them in different ways. In the exam, they might ask you to make your own. So I've got a column here. I always put my independent variable on the left. So I've got the concentration of the solution, and I have got 0, 0.25, 0.5, 0.75, and 0.1. Now, if you're using a table, you should have everything to the same amount of decimal places. So I'm just going to change all those so they are to 2 decimal places. You must have your unit at the top, don't include them at the bottom. So I've got the concentration of the solution, the initial mass of the potato, the final mass, and then I'm going to calculate the change, the percentage change in mass, the original length, the final length, the change in length, and the percentage change. Easy.
When we take the mass of something, we use one of these. Ooh, one of these. This isn't called a scale, it's called a balance. That's the correct apparatus. So what I'm going to do is I'm going to quickly take the mass of all of the potatoes and take the length of all the potatoes, and then I'm going to put them into the beakers depending on what concentration of liquid I'm going to use. Okay, so I'm just going to put all of them into the beakers, then I'm going to add the solutions. All of the lengths measured, all of the masses taken. I've put them in the appropriate columns of my table. And now what I'm going to do is add different solutions of, I'm using salt solution, but you can use starch solution, lots of different solutions. So if the concentration is very low, i.e. nothing, we have a high concentration of water. I would expect that to move through the partially permeable membranes of the cells into the potatoes and then maybe increase the mass, maybe. Or we would call this hypotonic, very low concentration. And then we should get something that is hypertonic, a very high concentration of salt. And we're assuming that means that the water might move from the potatoes in the cells in the potato out to the hypertonic solution to try and cause an equilibrium, maybe through those membranes in the cells. And we might see around the middle here where we would have something with a similar concentration of the salts that are in the potato. We might find that as an isotonic solution, we might find no change. We could find no net movement, maybe. I'm going to put in my concentration, so I'm going to leave them for about 20 minutes at least. Now, when we're doing this, you always, if you have to give a method, always give times. So I'm going to say 20 minutes, because that's how much you probably would get in a lesson by the time you faffed around taking all these measurements. Not faffing, analysing.
Always going to use, for a control variable, same volume of water and same volume of solution. Those of you that say amount will never get a mark when you're talking about a solution. I've got glitter on my face. When we're talking about liquids, always say volume, and we would use a measuring cylinder. Let's do this.
But now what I'm going to do is I'm going to remove them, and I am going to pat them dry just to remove the excess water from around the outside. That's a really important thing to do. And then I'm going to record their new masses and their new lengths. So now I have some results. Now what I need to do is I need to calculate change in mass and then the percentage change. And I do the percentage change by doing the change in mass divided by the initial mass and times that by 100, and that will give me the total percentage change. I can do the same for the length, but there isn't a huge amount of variation in length, so I'm actually only going to plot the percentage change in mass on a graph. And we can use that then to work out what the concentration of an isotonic solution would be. So what concentration of solution is in those cells, which is pretty cool. Now, I haven't repeated any of this. I haven't checked whether it's reproducible, so can someone else use my method and do the same thing? I'm only going to be plotting my results, so this would narrow the validity of my experiment. I should repeat it at least 3 times, but I'm not for today. But that is something to discuss, the repeatability and the reproducibility of our experiment. Let's do a graph. Now, it took me a few goes. I misplotted one. So it's small crosses, and then we find the point where isotonic, so that we are at an equilibrium. So we would have 0 net movement. Mass change. There's a percentage, and then concentration. Moles dm cubed. A graph to show. Bazinga.